4. What is a number? Suggestions? What's a number? No. What's that?
Not a letter or symbol.
It's not a letter or a symbol.
I
Okay.
put something that can be added or subtracted, like a variable or something like that.
Letter or symbol.
Negative infinity through infinity.
Something that can be added or subtracted. Okay, anyone else? Zoom friends, please chime in, participate.
Something with a value?
Something with a value, that's good, I like that. Check the drawer to the right of the sink.
Okay.
Okay, cool. Anyone else? Off to a good start. So let's see. Not a letter or a symbol. What do you mean by symbol? A symbol.
What?
Letters are kind of symbols,
Yeah,
but symbols that aren't letters.
wait, what? She said not a letter or a symbol.
Not a letter or symbol, but I'm not quite clear on what is a symbol.
Like add, subtract, greater than, less than. That's what I think of when I think of symbol. That's what I was.
Things like that.
Well, because I didn't want to say not a letter and be like, okay, so a symbol.
There's lots of other things.
Yeah.
Okay. So, all right, I'll take that. Now, something that can be added or subtracted,
Because
something.
you can't subtract the B
Like
from
I added a really nice bag on the back of my mountain bike the other day.
add or subtract in the multiplication world, not you added to the back of your truck. That's not the same. Two very different adds there.
Oh, okay.
Mathematical. Yeah, in the mathematical terms.
So a number is something that can be mathematically added.
If that's the way you want to put it, yeah.
Okay. What's a value?
Oh, I couldn't tell you.
So far I have questions about each of the things we have here. I'm not clear on the symbol thing. I'm not clear on the what can be added and subtracted yet. A number can be added and
We're doing our
subtracted.
best. Yeah.
Like we'll make sure. No. Well, there's more up there.
They're not
We
talking
got, oh no, we had some communication there. So what's a value? Help me out. Somebody online. What's a value?
Can I Google? Like,
Sure. You Google what is a value?
what's these a value? As a noun, the regard that something is held to deserve the importance, worth, or usefulness of something.
Okay.
As a verb, estimate the momentary worth of something.
Worth. Okay. Value.
Consider it to
Estimate
be
of worth.
important or beneficial with high opinion of.
Now, those don't quite fit with math. The closest one we had there was estimate of worth. So then I wonder, well, what's worth?
Oh my god. You can go down a rabbit trail, aren't you?
I'm gonna go down a rabbit hole here. Yes, thank you for pointing that out. So that's the point of this. Yeah.
Value in math refers to the numerical representation of worth of an object, quantity, or expression.
Okay, so we have worth or quantity. That's good.
Or expression.
Or expression. Expression seems a little too vague. Quantity, but we'll write it down anyway. Okay, so quantity seems the most meaningful here. So that's my next question. What is a quantity?
Amount.
An amount?
Yes.
Ooh, that's good. What's an amount?
Why are you doing this to us?
Where does all this come from?
Like, really, really old people who decided all this.
Really? So a number is a value. A value is a quantity.
And a math is a number, full cycle.
Pretty much. I mean, there's a few other words we could throw in here if we wanted to that all mean the same thing. The bottom line is when we try to communicate something like this, we make a cycle with our words, and it's impossible not to. Bottom line is you have to show me what it is.
So what's your?
You can't just tell me. You have to, if it was just as easy as telling me, kids would just get this stuff from the start, but they don't. So you got to show me what this is. Now, we've got a whole bunch of things mixed up here. So I'm going to break it down a little bit, and then we're going to keep working on this. So the idea of a number. Number is an idea.
How?
Yeah, it's an idea. What idea is it? It's the answer to, oops, extra symbol there. How many? And it doesn't matter whether we call that result number, or quantity, or value. They all mean the same thing. You just have to somehow show me how many. Now, we talked about this with a little bit before with sets. What was the big idea in sets that gave us the idea of number?
I don't remember, honestly.
One-to-one correspondence.
Oh, that's all of us. I thought it was like, I thought you were asking it.
Sets that have a one-to-one correspondence means they have the exact same quantity, the exact same answer to how many. Right? So if I wanted to answer the question, what does 3 mean? Yeah, right. Totally. You got to hold up your fingers and say it's this many things, or grab 3 oranges and say it's this many. You got to show it over and over again until kids get used to, oh, that many is 3. Like sometimes you'll see kids hold up fingers and say, I'm this many, right?
No.
So what does 3 mean? Bottom line is you have to show this with sets.
There's not really something you can verbally explain.
No, you can't. You got to show it. There's no other way to do it than show it with sets. You just show a whole bunch of sets that have that many. How many? The one we call 3. Does everybody call it 3? No. There's other languages.
Oh, but they all mean 3.
But they all mean 3, but they don't all say 3.
Okay, I thought you were saying
No.
everybody's 3 the same thing. I was like, yeah, I just said.
Yeah, so, but no, the word we say is not the same, right?
Yeah.
And the symbol, is this symbol the same everywhere? The answer is no,
No.
that's not uniform either. But we can all agree that that's 3. We can all agree that this is 3 things there.
Can you also
Right.
say like 1 more than 2? 1 less
If
than
they know
4?
what 2 is and 4 is, right? Because otherwise then it gets cyclical. The bottom line is it's got to get physical. It's got to be this many. All of the words we used are somehow based on physical reality or our emotional state. We're not going to go there though. All right. So number is an idea. That's huge.
Okay.
The way we articulate that idea differs all over the world, but we can all eventually agree whether we call it tres or trois or 3, it's this many. Okay. Then, aside from number, we have the idea of the symbols we use to communicate them. Those are called numerals. And the symbols we use are mostly used throughout the world, but there are some cultures that still use different symbols for these numerals. These ways we have of writing down the idea of a number like 3, or the idea of a number like 100, and so on. Okay. So big things here, right? 1, numbers 90. It answers the question, how many? 2, numeral is the way we write down the idea of a specific number. But our numerals are complicated. So I remember, I was excited when my kids learned to really count 1, 2, 3, 4, and then they got 5 and 6, and they could keep going. Eventually, they got beyond 10, which was super exciting. But then there's more complicated numbers, like let's pick or numbers or numerals. The year I moved to Pendleton, 1996. And there's lots of ways of reading that. I just said it as, right, 1996. Some people might read that as 1996. But what's the proper way to read it? 1996 is the proper way to read that. So that's the proper way to read that number, or that numeral. Is 1996 a numeral? It is. Yeah, this is an example of a numeral. Yeah, so that's an example of a numeral. Okay. But it's made up of multiple symbols, right? Correct. Anybody know what we call the symbols we use in our numerals? No.
Oh.
Number is an abstract idea that answers the question, how many? We're trying to be a little more precise with our language.
Oh, then I know.
They're called digits.
Oh, I think I could have got that. Like, oh.
So another idea number 3, is that we in our number system here use 10 digits. Oops, wrong direction. Go away. Curly bracket, let's try again. That's better. They are the set 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There isn't a single digit for 10.
It's 1, 0.
Because then we switch to place value. Yeah. So in our number system, we use digits with place value. So there's hidden meaning. And it takes kids a while to get used to that. Place value means each position has a separate meaning. What's the base for our place value? What is the base for our place value?
1.
No. So the 9, this 9 here is in what position? And this one right here is what position? And this one? Okay. And 10, 100, and 1,000 are all based on the same number, which is 10. Yeah. So we use base 10. So the base of 10 is used in our system. So when I write something like 1996 or 1996, again, that's a shorthand for saying I have one group of 1,000 and I have 9 groups of 100 and I have 9 groups of 10 and I have 6 ones. And when I explicitly state it out like that, that's called expanded form of a number. And sometimes that expanded form is used with exponents. So instead of writing it that way, I might write it as 1 times 10 to the third, and 9 times 10 to the second, and the other 9 times 10 to the first, and 1. Anybody remember what power of 10 that is? 0. So that's another way to expand, but with exponents. Next question. Why base a number system on 10?
It's a degree.
Why 10? Why is 10 easy?
Because, like, from.
Why not 9? Why not 16?
It's
Why not
inconvenient,
2?
because it's inconvenient.
How is it inconvenient?
Because I feel like it's easiest to do it on 10 because like your next, like your big number is kind of like you 1 through 9 is the core. You get like,
Why isn't it 1 through 4?
because that's just how the old people wanted it.
Yes, exactly. Somebody a long time ago decided they like 10 and made everybody else do it. But why 10? Why did some old person pick 10?
Because it was.
Let's say ancient person, ancient, because they're from a long time ago. They might have been young
Because
back then.
it was their favorite number. There's how many dogs they had,
Close,
how many sheep they had,
farther.
how many children they had.
Why 10?
I don't, you have the answers on that.
Yes.
I guessed about 27 times. So,
Hold up your hands.
with 10 fingers.
Ah, there you go. Yeah, it's most likely based on fingers, but there's 5 fingers on each hand. Why didn't we do it on 5?
They have 2 hands, so why not 10?
You have 2 feet too, and there's
Not
toes
everybody
there.
has 2 feet. Some people were born without feet.
Some people are born without hands too.
Less people.
Okay. It's most likely because of 10 fingers, but other societies throughout history have decided that 20 was a good number, 60 was a good number, 2,
No,
12.
no.
There's lots of them out there.
I understand.
So what we're going to experiment with is other systems. So I'm just going to give you a couple of notes and then we're going to do a new system. My favorite is the Mayan number system. Mayans had a base 20 number system
So then
with 3 digits.
what?
Yep. Yeah, we'll play with Mayan later. Babylonians. Oops, missed the letter there. They had a base 60 number system with 2 digits.
I don't get the 2 digit, 3 digit. thing.
Yeah, we'll play with those later. Romans. Theirs wasn't really a base system. It was more of an additive system because they didn't have place value. Egyptians were pretty similar. Almost identical, slightly with different symbols. And you're probably familiar with Roman numerals a little bit. You've seen them before. Yeah, the position of the number doesn't matter so much, or they tended to list them from largest to smallest. Egyptians did something similar. We all use computers. Computers use a binary system.
1 is 0.
So binary is base 2 instead of base 10. And our binary system has 2 digits. Computer colors are different. That's related.
Are we gonna need to know these?
Yeah.
Make sure I'm not writing this down for nothing.
Everything but the computer colors is in the book. The computer colors I'll do separately. Computer colors use base 16. It's also referred to as hexadecimal. Hexa meaning 6, decimal meaning 10, so 6 and 10. and 16 digits. We'll check that out later. So I want to pick something in between. Base 2 seems kind of easy because you just have zeros and ones, but it's a bit of work because the numbers, the numerals get longer. We're going to play around with base 5. And a good model that I'm going to use with you guys for playing with base 5 is I'm going to use coins. And we're going to work with quarters, nickels, and pennies. So if I model a base 5 system after our base 10 system, then it's going to be based on powers of 5 for place value. Actually, I'm going to write groups of 5 instead. And we're going to use 5 digits. So I don't want to write the numeral 5. I'm going to write the word there. So digits that are important. 0 is one of the most important digits. 1 is a good one. 2, 3, 4. There's my 5 digits. As far as the place values go, like in a base 10 number system, they're based on powers of 10. In a base 5 system, we're based on powers of 5. So for example, if I wrote a number down like 3, 4, 1, 2, and I claim that number is based on 5 instead of 10, then working from the low end up, there's got to be 2 ones, right? That's our usual ones place. And the next place, instead of the tens place, has to be what place? It has to be the 5 place. So that would mean I have 1 group of 5.
Wouldn't that change the number though?
You'll see. I'm just, and this should be a plus there, a little messy. Well. And then the 4, what place would that be in? Well, if we look at our number system,
Oh, 50.
it would be the 5 squareds instead of 10 squareds. Because we're groups of 5, right? So I would have 5 groups of 5, which would be 25. That'd be the 25's place. So I would have 4 groups of 25. If you have 5 groups of 25, that would be the next place. How many is 5 groups of 25?
5 groups of 25,
Mm-hmm.
125.
Mm-hmm. That would be the 125's place. Okay. So these are all powers of 5. The 1 is 5 to the power 0. The 5 is 5 to the power 1. 25 is 5 to the power 2. 125 is 5 to the power 3. So if some other civilization used a base 5 number system, I could then translate what that number, that numeral right there means in our system by just naming the place values. So let's see, if I have 3 125s, that's going to be 375. 425 is going to be 100. I got a 5 and 2 1s. So that's going to be 487.
2.
5, 82. Yeah. Oh, let's see. There's going to say 400.
No, you're right.
5 makes it 80. Oh, yeah, 482. Yeah, thank you. So that's what this would be in base 10. In the book, you're going to see a few different number systems in there, base 5, base 4, base 2, base 12. It's important that we write what base we're in. If it's not written, we assume it's base 10, but you could always write it explicitly. So 482 things in our number system is the same as 3412 in base 5. Now, I don't want to read that as 3,412 because that's not 3,000 and that's not 400.
Yeah.
I'm just going to call it 3412 base 5. Okay. So we're going to try and get used to a base 5 number system. Ready?
Sure.
Good. All right, so here's what I want you to do. I want you to try and count in base 5 with me. Now, this is tricky. This is like the first day of kindergarten. And some kids
Yeah.
don't know how to count. So we have 1,
I thought it would be 0.
well, we start counting at 1, right?
That's pretty sure.
Yeah, so we're just counting. So we usually, so we, 0 is a digit, but we don't count it.
I count with it. Okay, 2,
So counting in base 5, 2,
3, 4.
3, 4. Now, here's the thing you have to think of on base 5, you have to group by 5. Every time you find a group of 5, you need to jump to the
Yeah.
next place.
But
So to
where are we
write
jumping?
5, it's got to be a 1, 0, because that says one group of 5 and no ones. So
So
that
then
right there in
just-
base 5 says 1, 5, and
And
no
0,
ones.
Okay, and then it would be 11, 12.
Okay, we don't want to call it 11.
Okay, but
It would be a
one,
group
one,
of 5 and a 1. That's how we would
1,
write
2, 1,
6.
3, 1, 4.
And then a group of 5 and 2 ones would be 7. A group of 5 and
8.
3 ones is how we would write 8. We can still call it 8, but it's a group of 5 and 3
Okay, and
ones.
then 9.
And then we're going to have 9 would be a group of 5 and 4
And then it would be
ones.
2, 0.
And then 2 5s and no ones would be how we would write 10 in a base 5 number system. And we can keep on going. We'll play some more later. All right, so we're going to play a game to try and get used to this. And the game that we're going to play, so again, what I'm doing here is counting in base 5. We'll do more of that later. Now, it would help if we had real coins, but I'm not sure that our virtual audience has access to real coins. I have a bunch I can grab for my live people here in a minute, but you're certainly going to need dice. So the game that we're going to play is make 2 quarters. And to do this, you're going to make a table. And in your table, we're going to roll dice and keep track of our roll. And then after we roll, we're going to keep track of the number of quarters, nickels, and dimes that we've collected. So I'm going to get it started with you, and then I'm going to set you guys free to do it.
You want to start in
pennies, sorry.
quarters?
Quarters, nickels, pennies. Yeah, right, just like I am. I'm going to keep track of quarters, nickels, and pennies. All right, I got some dice here. If you don't have access to dice, there's virtual dice here. Kat. So I'm gonna roll on the floor onto the desk. I got a 9. Oh wait, it's a 6. All right, now. Then I need a bank of money. Okay, so I have 2 choices. I could just go grab 6 pennies, but what's the better way to give change for 6 cents? Yep, so it'd be 1 nickel and 1 penny. So that's what I'm gonna write in my table. Then I'm gonna roll again. All right. What is
Then
one?
why do we need quarters if there's no number over 6?
We want, so the game is called Make 2 Quarters. We're gonna keep collecting money.
Oh, so the next one, it would be like 6.
We're gonna add it on to
Okay.
whatever we get. Yeah, so give me a number you got. You got a 2 and you got a 5. Okay, so I'm gonna do the 2 next. So if I roll a 2, then I'm just gonna have now 3 pennies and 1 nickel. All right, I'm adding it on to what I have. And then you rolled a 5. So let's say we rolled a 5 next. Well, that's just gonna give me another nickel. So now I have 2 nickels and 3 pennies. Now let's suppose I roll a 4 next. So if I roll a 4 next, that's gonna give me a total of 7 pennies. Is that a good thing? Yeah, so I'm gonna have to say, no, that's really 2 pennies and another nickel. Now, you can either add it in your head or cross out as you go, but I want you to keep doing this, keep rolling a die and adding up that many pennies, but always trading up. And eventually you're gonna start getting quarters. If you search for virtual dice, there's lots of apps out there for it. Virtual dice. Google has a lovely one right there that you can just keep rolling all over and over again. So if you haven't already, please start building this table and rolling. And we'll come back and check on this in just a minute. So I kept rolling over here and
So what if we go past?
yeah, you could go past. That's fine.
-3.
It's okay to go negative on the next game. So to check that I did this right, I'm going to add up all of my rolls and see if it works out. And you can see that I crossed some stuff out because I made a mistake. So I had to go back and find my mistake. When you add up your roll, it should match whatever you say your quarters, nickels, and pennies are at the end. The next game is to lose 3/4. And sometimes, say, to get from this row here to this row here, you've got to do some work off to the side.
The one that made me the most mad was I had 2/4, 1 penny.
So then I'm gonna roll, I get a 1, a 4, a 1, a 2, a 2, a 5. So sometimes it's kind of slow going. I get another 5, a 1, a 6, bunch of 5s in a row. So let's see, taking away 1 is pretty easy. Taking away 4, I gotta borrow. So if I borrow a nickel, that's 7. Minus 4 is 3.
Now,
Borrow, subtract. 5s are nice.
list for 30.
And then we're going to keep going. All right, the next thing, once we finish that, and again, to check this, I'm going to add up all my rolls and see if they match where I left off. And I'll show that in a few minutes.
No matter the numerical system,
Yeah,
like, if it's base 6, the 6th number would technically be written as our 10, correct?
yes, yeah, whatever the base is, exactly. Yeah, so the next one, we want to come up with the first 30 counting numerals. Now, we already have the first 10 from earlier, so I just want to keep going. I'm just going to add that here.
Oh, this is easy.
So my next one would be a 2-1, a 2-2, a 2-3,
Oh, I'm at
a
30.
2-4. Now I got to pause for a second.
Pause time. Give me a
So
30.
this means right here, I have 2 5s and a 4, right?
That's
So that's 14. Next is 15, which would be 3 5s and no 1s.
So do you want the first 30 numerical up to 30 or the first 30 physical?
First 30 physical
Okay.
numerals, yeah. So right now, this right here is 15 in base 10.
Basically, we're on 60.
Really? We'll see.
Base 15 is. Oh, 50. No, yeah, I'm at 60. So how do you check your work?
Okay. So I'm gonna come back to this one in a minute here. I'm stuck at 4-4.
Then 5. 0, because it's 5.
Okay, so but I gotta back up a second here, because what digits do I have to work with again? 0, 1, 2, 3, and 4. Those are
So
the
then
only
would it
digits you
also
can
be
write
100?
down.
50.
We can't call it 100
But
because
it-
that means something else, but you're right, it would be
Well-
1, 0, 0. Yeah, there you go. Okay, hang on, I'm gonna get to let me write this down, then I'll get to the check on that one. Yeah, so the next one here would be 1, 0, 0, which is a group of 25, no 5s, no 1s. So that right there would be 25 in base 10.
Okay. 40. Base 5.
So this would be 26, 27, 28,
Oh, wait,
29,
So after, what,
This is 29.
110.
110, and again, oops, 110, what does that mean? It means I have 125, hang on, and I have 15, and I have no ones. 25 and 5 is definitely 30 in base 10. I'm just checking that that is the 30th digit, or numeral, excuse me, in base 5. 100.
So then
We'll call it
after
100.
444, would it be 500, 500?
What digits do we have to work with?
So I'm right.
Is there a 5 digit?
I mean, would it be 1000?
1000, which we shouldn't call 1000.
Easy.
It's not.
Okay,
This is mind blowing, and it's
Can I just-
supposed to be.
can I just take a picture of this? Does that work?
So I want to go back and start checking my work. Sure. I would love to wait.
It's not loading. Okay.
Now, I'm not, so I can check my work kind of the same way I did here. Now, I'm not ready to check my work because I'm not done, but what I would do when I am done, maybe you hit exactly 3/4 in the end and get to 0. Maybe you went over and went negative. If you add up your rolls, it should be about, let's see, what is 3/4 worth?
75.
Yeah, it should be around, it should be close to 75, and then whatever extra that you have. So if you add up your rolls, you can check that. So I'm gonna keep doing mine and see how I got a ways to go, looks like.
So is the homework assignment more of like the base 5, base things like that? Or like what should we expect?
The homework assignment is, except for one thing, pretty much straight out of the problems in the book. And I'll get to that in just a minute.
Well, it is. Can we use your example for 136 as one of them?
Oh, for the next one, we'll
Or do I have to do
chill just a minute.
Okay,
Let me catch up.
ORED.
Reminder about base 5.
What?
We're grouping by 5. And the digits that we have to work with are 0, 1, 2, 3, and 4. So in base 5, you are never going to write that digit down. It's illegal, doesn't exist.
What? Oh, correct.
That one right there. So once I get to a 4 is like a 9 in base 10. I got to jump to the next place value. What's right before 100? Well, up here, I can see what's that. And right before that should be that, 43, 44.
76.
Is that all for that?
And that's the end of that too.
Okay. Work is not me in a mess of someone.